students. I am Dr. Megha Bhamare, working as Assistant Professor in KVN Naik College, Nashik. In this session, we are going to learn about operations on sets. There are various operations on sets such as union of sets, intersection of sets, complement of a set, difference of sets, symmetric difference of sets, and disjoint sets. Now, let us begin with the first operation, union of sets. Union of two sets is a set obtained by collecting all the elements of both sets. Union of two sets is denoted by A union B and is defined as the set of elements of X such that X belongs to A or X belongs to B. In this Venn diagram, U is the universal set, A and B are subsets of U. Then A union B is the shaded region in the diagram, which is collection of all elements of A and B. Now we go to the intersection of sets. It is the set of common elements of both sets A and B. It is denoted by A intersection B and is defined as the set of elements of X such that X belongs to A and X belongs to B. In this Venn diagram, shaded region is A intersection B. That is, we take common elements of A and B. Next is complement of a set. It is the set of all elements of universal set which do not belong to set A. It is denoted by A dash or A raised to C. It is the set of elements X such that X belongs to U but X does not belongs to A. If U is universal set and A is subset of U, then shaded region is A complement. It is the set U minus A also. We have already understood the concept of complement of a set, and this concept will easily make you understand De Morgan's law. Let us see De Morgan's law. If U is universal set, A and B are subsets of U, then A union B complement is equal to A complement intersection of B complement and its dual is A intersection B whole complement is equal to A complement union of B complement. Now, difference set. The difference set of A and B is the set of elements which are in A but not in B. It is denoted by A minus B and it is the set of elements X such that X belongs to A but X does not belongs to B. Here A and B are subsets of universal set U. Then shaded region is A minus B. Symmetric difference of sets. Symmetric difference of sets A and B is the union of different set of A and B and different set of B and A. That is, we have to find A minus B union of B minus A. Now we consider U as universal set. A and B are subsets of U. First we find A minus B, that is different set of A and B, and then we find B minus A, that is different set of B and A. Then we take union of them and we get symmetric difference of set A and B. If we observe that we get symmetric difference of A and B is the set of elements A union B minus A intersection B. Okay, let us go to the disjoint sets. If U is the universal set of college students, A is the set of boys and B is the set of girls, then there will be no common elements between set A and set B. Hence, we can say that set A and set B are disjoint sets because there is no common elements between A and B, and it is denoted by phi, that is empty sets. Now, let us take an example. If U is the universal set consists elements 1 to 9, set A consists 1, 2, 3, 4, set B consists 2, 4, 6, 8, and set C consists 3, 4, 5, 6. Here A, B, and C are subsets of universal set U. Then we have to find A union B, A intersection B, A complement, difference of B and C. Also we have to find symmetric difference of A and B. First one is A union B. It is the set of elements X such that X belongs to A or X belongs to B. That is, we collect all elements of set A and set B. Here, in set A, there are elements 1, 2, 3, 4 and set B 2, 4, 6, 8. 2 and 4 are common elements between them. Therefore, first we write 2 and 4 in the set of A union B. Then we write all remaining elements from set A and set B. And therefore we get A union B is equal to 1, 2, 3, 4, 6 and 8. Second one is A intersection B. A intersection B is the set of elements X such that X belongs to A and X belongs to B. That is, we have to take common elements between A and B. Here we observe that 2 and 4 are common elements between A and B. Therefore, A intersection B is the set of elements 2 and 4. Now we find A complement. A complement is a set of elements X such that X belongs to U and X does not belongs to A. In universal set, 1 to 9 are elements and in set A there are 1, 2, 3, 4. In these two sets, 1, 2, 3, 4 are common elements. But in A complement, we delete the common elements and we write only remaining elements of set U. And we get A complement is equal to 5, 6, 7, 8, 9. Different set of B and C. It is a set of elements X such that X belongs to B and X does not belongs to C. That is, we have to remove the elements of C from set B. If set B consists 2, 4, 6, 8, then elements of C are in B are 4 and 6. Therefore, in set B minus C, we will get 2 and 8. Now, we have to find symmetric difference of A and B. So, we first find different set of A and B. Different set of A and B is the set of elements X such that X belongs to A and X does not belongs to B. That is, delete the elements or remove the elements of B from set A. Here, 2 and 4 are the elements of set B which are in A. Removing these two elements, we will get 1 and 3 is the set of different set of A and B. Now, different set of B and A is the set of elements X such that X belongs to B and X does not belongs to A. Here we take set of elements B as 2, 4, 6, 8 and 2 and 4 are the elements of set A which are in set B. Therefore, by removing 2 and 4, we will get 6 and 8 are the elements of different set of B and A. But we have to find symmetric difference of A and B. we have different set of A and B as 1 and 3 and different set of B and A are 6 and 8. Therefore, we write union of 1 and 3 and union of 6 and 8 are 1, 3, 6, 8. That is, x belongs to open interval minus 1 comma 2 and x belongs to semi-closed interval 1 comma 3. Here x lies between minus 1 and 2 and x is greater than or equal to 1 less than 3. These two conditions are satisfied only if x is greater than or equal to 1 and less than 2. Hence we say that A intersection B is equal to open interval 1 comma 2. Now we find different set of A and B. That is, x belongs to A and x does not belongs to B. That is, x belongs to open interval minus 1 comma 2 and x does not belongs to semi-closed interval 1 comma 3. That is, we take elements of x is greater than minus 1 and less than 2 and x is less than 1 because x does not belongs to 1 and 3 means x does not greater than or equal to 1. Therefore, we take x less than 1 and which is satisfied only if x belongs to open interval minus 1 comma 1. Hence, we say that different set of A and B is equal to minus 1 comma 1. Now, we find A complement. That is, x belongs to R and x does not belongs to A. That is, x is less than or equal to minus 1 or x is greater than or equal to 2 because set A is an open interval of elements minus 1 comma 2 which satisfy only if x belongs to minus infinity comma minus 1 or x belongs to open interval 2 comma infinity. And hence we say that A complement is the set of elements minus infinity comma minus 1 union of open interval 2 comma infinity. Now we take another example, that is, prove that A intersection B union of C is equal to A intersection C union of B intersection C. Now we find solution for this example. Let x is an element of A intersection B union of C. That is, x is an element of A intersection B or x is an element of C. That is, x belongs to A and x belongs to B or x belongs to C. Hence, we can say that x belongs to A or x belongs to C and x belongs to B or x belongs to C. That is, we get x belongs to A union C and x belongs to B intersection C. And hence we can say that x belongs to A union C. We can write symbol that is intersection x belongs to B intersection C. And hence x is an element of A union C intersection of B intersection C. And therefore we get A intersection B union of C is a subset of A intersection C union of B intersection C. Similarly, we can prove that A intersection C union of B intersection C is a subset of A intersection B union of C. And therefore, from these two equations 1 and 2, we can say that A intersection B union of C is equal to A intersection C union of B intersection C.